Imagine floating far above the Milky Way, watching its spiral arms sweep like slow fireworks. Zoom in past nebulae, planets, cells, atoms, till the familiar dissolves into abstraction at about 10 to the power minus 35 meters, 20 orders of magnitude beneath a proton. Every theoretical roadmap falters. This is the Planck length, often portrayed as nature's final decimal place. A scale so small that distance itself may fragment into quantum pixels. Why suspect such granularity? Because to measure position ever more precisely, you must probe with ever shorter wavelengths, higher energies that eventually would fold space upon itself, forging tiny black holes. Beyond that brink, the very concept of where blurs. Space-time foams like boiling water, frothing with momentary tunnels and twists. Two mirrors placed closer than a Planck length could not reflect light in synchrony. Uncertainty would shove them apart. In this view, Einstein's smooth fabric is a zoomed-out illusion. It's like a photograph that conceals its dot pattern until you press your nose to the glass. Physicists liken the Planck scale to the weave of a carpet. From across the room, the carpet seems continuous. Under a magnifying glass, knots and fibers appear. We have not yet built an instrument sharp enough to glimpse those knots, but cosmic clues hint they are there. The maximum information a black hole horizon can hold. The tiniest jitter in gravitational wave phases. It's the fact that nothing outruns light. All whisper that space-time may be less a stage and more a tapestry whose threads we are only beginning to discern. Your takeaway. Beneath the calm curves of relativity, space-time may resolve into Planck-scale pixels. Tiny knots that set the ultimate limit on here and there. Picture a vast social network. Friends, families, colleagues, linked by invisible ties of familiarity. Two strangers separated by oceans can feel close if mutual friends knit a short path between them. Now replace people with quantum particles, friendships with entanglement. And you have a provocative idea. Distance might be nothing more than the pattern of who is linked to whom. In 2013, theorists Leonard Susskind and Juan Maldacena proposed a cryptic equation. ER equals EPR. On the left, Einstein-Rosen ER bridges, wormholes that bend spacetime into tunnels. On the right, Einstein-Podolsky-Rosen EPR pairs. Entangled particles, sharing a unified quantum state, conjecture suggests these two notions are different faces of one underlying fabric. Stitch two particles with entanglement, and a microscopic wormhole lurks between them. Non-traversable, but real enough to define connectivity. Under this lens, space-time is not laid out like graph paper. It is woven from correlations. High entanglement density means threads pulled tight, regions feel nearby. While sparse entanglement lets the fabric sag, regions drift apart. Black hole horizon, saturated with entanglement, becomes a densely stitched curtain. Sever enough threads, and the curtain frays, echoing the black hole information paradox. Laboratory hints already glimmer. In certain quantum simulators, engineers dial entanglement patterns and watch effective geometry curve or flatten in response. It's as if friendship links on a social graph were rearranged, causing entire neighborhoods to drift nearer or farther without moving a house. Your takeaway. Entanglement may be the loom on which distance itself is woven. An unseen network whose connectivity decides what counts as far and what counts as near. Hold a credit card to the light, and the tiny hologram shimmers. A three-dimensional image conjured from a two-dimensional foil. Black holes, those dark sentinels of the cosmos, hint that reality may employ a similar trick on the grandest stage. When Jacob Bekenstein and Stephen Hawking studied black hole thermodynamics, they discovered a startling rule. The entropy, meaning the information content of a black hole, scales not with its volume, but with the area of its event horizon. Pack twice as much matter inside, and the informational budget grows only with the surface. As though every new byte must fit on a horizon-wide memory card. Extend that principle beyond black holes, and you arrive at the holographic hypothesis. Perhaps our entire universe is like the credit card foil. Its three-dimensional happenings encoded on a distant two-dimensional boundary. In some mathematical arenas, space-times with a negative curvature called ADS. This notion becomes precise. Gravity in the bulk equals a quantum field theory on the border. A cosmic translation dictionary known as a DSCFT, duality. Even our accelerating universe, more de Sitter-like than ADS, may whisper holographic hints. Cosmic microwave background data show information stamped on a spherical horizon 46 billion light-years away, our observable edge. If the hologram idea extends here, then the drama of galaxies, life and thought could be a richly rendered interior generated by pixels on that remote screen. Your takeaway? Black hole physics suggests the universe may be a hologram, its deep volumes encoded on faraway surfaces, turning space itself into a grand projection. When engineers guard your cloud photos, they scatter each file across multiple servers. Lose one hard drive, and the picture survives. Error correction by redundancy. Astonishingly, cutting-edge theory proposes that space-time knits itself together by the very same strategy. In tensor network models like MERA, physicists represent quantum entanglement as a layered web of nodes and links. Feed in a pattern of intertwined qubits in a curved geometry, complete with gravitational behavior emerges from the mathematics. Here's the key. Remove or scramble a few qubits deep inside the web, and the larger pattern endures. The network's entanglement redistributes the missing information, healing small wounds much like a geodesic dome transfers stress. That robustness mirrors spacetime's resilience. Poke a tiny hole in the vacuum with particle experiments, and the fabric flexes, but does not tear. Gravity's smoothness may be the macroscopic face of an error-correcting code humming beneath. Laboratory analogs already sketch the idea. In superconducting circuits, researchers entangle microwave photons into surface codes that self-repair against local noise. The logical qubit lives not in any single photon, but in the global weave, an echo of how a chunk of space might reside in correlations rather than points. Scaling such systems could let physicists build toy universes, watching geometry morph as they tweak the code. If correct, gravity's gentle insistence on keeping the cosmos continuous is neither magic nor coincidence, is information theory writ large. Redundancy ensuring the stage stays intact, so the cosmic play can proceed. Your takeaway: spacetime's smooth fabric may arise from quantum error correction, with entanglement redundancy acting as the unseen mason that keeps the universe whole. For decades, quantum gravity lived only on chalkboards, symbols nested within symbols, forever beyond the reach of instrumentation. But the experimental tide is turning. Engineers are fashioning stethoscopes, sensitive enough to eavesdrop on the Planck scale whisper. Begin with gravitational wave echoes. When two black holes collide, LIGO records a dying chirp. Some theories predict faint, later reflections, ripples bouncing off quantum corrections near the horizon. Analysts now comb petabytes of data, stacking events to amplify any echoes a billion times fainter than the main shout. A positive signal would be our first acoustic portrait of spacetime's microscopic grain. Closer to Earth, diamond anvils and optical traps cradle nanoparticles, 1,000th the width of a hair. Researchers cool these beads into quantum superposition, two locations at once, separated by mere nanometers. Let Earth's gravity act on both arms of the superposition. And any deviations from Newton's script could hint at quantum gravitational influences, surfacing not in distant quasars, but on a bench dot. Even radio astronomers have joined the hunt. Pulsar, timing arrays, galactic metronomes spread over the Milky Way. Listen for dewdrop-sized fluctuations in signal arrival times. A jitter unaccounted for by cosmic dust or dark matter might betray space-time foam. Each Planck-scale jitter, adding its microsecond signature to the centuries-long beat. Pull off these feats, scientists borrow tricks we met earlier: squeezed light, superconducting qubits, cold atom interferometers. The same field mastery that weighs viruses and maps brain tissue is now repurposed to weigh the very fabric of the cosmos. Your takeaway: quantum gravity moved from blackboard conjecture to lab challenge. The first delicate instruments now press an ear to space-time's deepest murmur. We have wandered from Newton's apple to vibrating graphene, from laboratory horizons to cosmic holograms. Along the way, A pattern emerged. Reality is woven, not built. Fields ripple, entanglement knots, error-correcting codes, patch holes, and even emptiness hums with possibility. Each layer we peeled back revealed another loom beneath, spinning finer threads. Yet questions dangle like loose yarn at the border. What ties quantum information to the arc of gravity with absolute rigor? How do dark matter and dark energy stitch themselves into a picture seemingly tailored without them? Can entanglement alone explain the arrow of time, the spark of consciousness, the birth of the first star? Our series will close by confronting these open seams. Episode 10, Reality is Relationships, gathers every strand. Gravity's shape, quantum's dice, symmetry's code, inertia's stage, the restless vacuum. Lab-made universes, and space-time's emergent weave, into one tapestry of connectedness. The finale will ask not merely what the universe is, but why its fabric allows meaning, memory, and marvel. For now, stand beneath the night sky once more. Recognize that the distance between you and Andromeda, the rhythm of your heartbeat, and the glow of your phone screen are all expressions of a single, ongoing act of weaving. We are threads within the loom, conscious knots briefly aware of the pattern unfolding around us, and perhaps with curiosity a shuttle, capable of adding a stitch or two of our own. Your last takeaway for tonight? At the loom's edge, we glimpse unfinished cloth. Questions still unraveled, setting the stage for our final meditation on a cosmos made of pure relationships. Stand outside on a wind-stilled evening. The sky hangs like dark velvet, punctured by points older than Earth itself. To the naked eye, it feels complete, its unchanging constellations, planets tracing familiar loops, a moon that has risen and set for every ancestor you have ever had. But listen a moment longer, past the crickets, past your own pulse, and imagine the hush alive with inaudible weaving. First come the fields, unseen oceans, whose gentle ripples become electrons, photons, quarks. They are the loom's first threads, caught across all of space and time, yet the weave does not end there. Entanglement knots those threads into patterns that define nearness and distance, carving valleys we call gravity, stretching sheets we label spacetime. Even the vacuum, which we once dismissed as nothingness, is thick with jitter, an ever-busy shuttle adding texture to the cloth. Human hands have begun to imitate the craft. We coax electrons into frictionless rivers, twist carbon until massless quasi-particles race across a tabletop, trap atoms in lattice of light that echo the mathematics of black hole horizons. Each experiment is a pocket universe, proof that the rules we revere can bend, fracture, or bloom into entirely new sets when the underlying weave is retuned. And still the loom hums beyond our reach. Planck-scale knots may pixelate reality more finely than any microscope will ever resolve. Dark matter prowls between the stitches. Dark energy tugs the fabric outward faster each epoch, as though an unseen hand were tightening a cosmic frame. We have traced the pattern far, yet the edges fray into questions more profound than any answer we have yet secured. What does it mean to live inside a tapestry forever in the making? It means solidity is an illusion of scale. Every stone, thought, and heartbeat is a momentary standing wave in a deeper sea. It means discovery is not a conquest, but a conversation with the loom itself, its measurement a polite request. Each paradox an invitation to look closer. So the next time you tap your phone, ride a levitating train, or gaze at the Milky Way swirling over a quiet lake, remember, you are engaging with fabrics both ancient and newborn. The charge that powers your screen, the superconducting hush beneath a hospital magnet, and the spiral arms arcing through space all arise from the same silent workmanship. This is cosmic canvas, where the universe is not only studied, but painted in meaning. Until next time, keep asking, keep looking up, and never stop wondering.